There's a SharePoint vulnerability that is being exploited in the wild right now, and it is a big deal. It is causing a lot of pain for cyber defenders. I want to quickly show you how to use attack flow to document and visualize this campaign, and then use that to communicate to your coworkers and your leadership. Let's dive in. So this is what our attack flow looks like for this campaign, but before I dive into this with you, I do want to show you a little bit about how I created this flow in the first place. So if you take a look at the flow properties on the side here, you'll see that I've cited several sources. And these sources are open in tabs over here. So first of all, I use this Akamai blog post. This blog post has really great technical detail. It goes into the exploit chain and also some of the post-compromise behavior. To supplement this, I also used this Palo Alto Unit 42 blog. This one has a little variation on the post-exploitation behavior, but the exploit chain is the same. So this just adds a little bit more of a kind of well-rounded intelligence to the flow. And then finally, I consulted this Varonis blog. This one actually touches on the view state mechanism and the use of the machine key. And so that's actually a really important part of why this vulnerability is such a big deal. So that's kind of the sources I consulted. And then just to give you a little bit of insight into the process, I took notes on these, started just copying and pasting little snippets from each report, kind of organizing it into how I wanted my flow to go, and then starting to map this into MITRE ATT&CK TTP. So you can see here, for example, map this first exploit to this T0819, which is a TTP in MITRE ATT&CK for basically exploiting a public-facing application. We have gone over this kind of MITRE ATT&CK mapping process in our attack flow training that we recently released, but I'll just give you kind of a quick look at how I do that here. So there's a couple ways to approach this. One is to go to the MITRE ATT&CK website and just use this search feature. So this makes it easy to search for keywords. This will search across all of the MITRE ATT&CK content. Another way to do this that's a little bit more targeted is to come to the tactics page, which is right here. And then when you know which tactic you want to map to, you can drill down and then look at the TTPs grouped under that tactic. This just helps you kind of weed out a lot of items in MITRE ATT&CK that will come up in the search bar, but are not really relevant to what you're looking at. So for example, most flows are going to start with initial access, and then we're probably looking at what execution mechanism did they use. So using this tactic-oriented approach is a good way to get started. The third way to do this is to use the attack-powered suite browser plugin. This is a browser add-on. This is free and open source. The Center for Threat Informed Defense created this. And this is really nice because, let me show you an example here. We know there's several exploits that are run here. Here's the technique for exploit public-facing application in MITRE ATT&CK. And so it's really easy to find things using attack-powered suite, but then it also has these little copy snippets at the bottom. And so this makes it really easy to grab things from here and put them into my notebook. So for example, I can click this link button. You'll see that copies. And I come over to my notebook, and then I can just paste that in here. And so that will go and grab the ID for me. It grabs the technique name. It also makes this a working link. So later on, if I'm looking at my notes and I want to refresh my memory, it's just one click to get me back into MITRE ATT&CK and read the details of what this TTP is. Okay, so now we're going to take a closer look at this attack flow. And before we zoom in, I want to start just kind of at this high level and just take a look at the shape of the flow. So up at the top here, we have this initial set of techniques that is kind of common across these three campaigns we've seen. But in the middle here, what we see is a variation in the behavior, where these different campaigns are actually using different steps. These are different post-exploitation steps. And then at the end, regardless of what that post-exploitation looked like, there is this final technique here that all these campaigns share. And this is actually one of the most important parts of this threat. And we'll come back to this at the end because this is really key to understanding why this particular vulnerability has been such a big deal. So we can start off by zooming in up here, and we see that this attack starts off with these two actions that are each exploiting a CVE. One of the things that's great about attack flow is that we can just link in relevant context directly to the flow. So we can see here, for example, the first CVE that gets exploited. This is an authentication bypass CVE. So we can see that that's kind of step one here. Over here, we've got this indicator showing what the target URL is for this exploit. And then also on this side, the authentication bypass uses a forged referrer header. And so we can include the value of that referrer header into the flow. This is a great technical detail that your detections or threat hunt team could go use to look for this behavior. Moving on, the second action here is the second vulnerability that gets exploited. This is a deserialization vulnerability that allows for remote code execution. And once again, we can just link in the exact CVE number. In particular, when you've got exploit chains like this and you've got multiple CVEs, it can be easy to lose track of what each CVE is actually doing and how the adversary is piecing that together into a complete attack. And so one of the things about attack flow that's really nice is it lets you clearly see the relationship between these behaviors over here and the vulnerabilities that they're exploiting. So moving on, kind of in all three of these campaigns, we see that the initial payload uses PowerShell execution, so that deserialization exploit is executing a PowerShell payload. But then what we see happens next is that the post-exploitation shows different behaviors, different variants in different campaigns. And so there's kind of three distinct variants here that we'll walk through. So the first one is over here. This is the one described in the Akamai report. Unit 42 also touches on this. They call this variation 2. But in this scenario, what the adversary does is they drop this web shell. It's an ASPX file, and it's capable of extracting cryptographic signing keys. Once again, it's really nice in attack flow to be able to drop indicators right into your flow. So you're kind of blending this behavioral point of view with this more traditional IOC point of view. So we can see things like this is the file name that gets dropped. These are the IP addresses associated with this particular campaign, DNS name. And so we can kind of all see that in one place. So this web shell uses reflective code loading. This accesses the web configuration in memory. And then that payload uses that API to extract the machine key. So this is the machine key that is used by the web server for various cryptographic signatures. And then finally, that machine key is exfiltrated back over that C2 channel, back through the web shell. So that's kind of the first set of post-exploitation behaviors. If we come back up here, we can see the second set. This is what Unit 42 calls variation 1. And in this case, it doesn't drop a web shell. It actually behaves a little bit differently. The payload includes logic to iterate over the web root, and it looks for web.config files. These are the sorts of files where machine keys would be stored. Once it has collected all of those web config files, it dumps them all into a new file called debug.dev.js. And once again, we can add this indicator here. So we've got this very long and specific path where this particular campaign was staging this file. And then, as with the first attack path, that gets exfiltrated back over the C2 channel. So these two paths have kind of similar outcomes in the sense that they are both searching for and then exfiltrating that machine key. And then we'll take a quick look at the third path. This is what Unit 42 calls variation 3. This one is actually really similar to the first path we looked at. The big difference here is that initial PowerShell payload is base64 encoded, but then we can see that it still uses reflective code loading, just as in that first path. We get a little bit more detailed IOCs here, a couple paths where this web shell gets dropped to, so that's really nice to have in the flow. And then extracting the key from memory, exfiltrating it back over the C2 channel. And so what we can see here really clearly in the attack flow is that although there's a little bit of variation in that initial post-exploitation behavior, all three of these campaigns end up in kind of the same end state here, which is that the attacker has now stolen the machine key, and they can use that to forge the view state token, which is a feature of ASP.NET that is intended to allow for statefulness in web applications. But in this case, this is actually used as a persistence mechanism. So you'll notice that I tagged this action using the persistence tactic in MITRE ATT&CK. I did not tag it with any techniques because there's not really a technique in MITRE ATT&CK that describes using view state in this way. And so this really goes to the core of this vulnerability and why this has been such a big deal, because even if you patch the CVEs, even if you find the web shells and remove them, once the attacker has that machine key, they're able to forge the view state, and that allows them to get code execution. And so this becomes difficult to eradicate. You actually have to go through and roll all of those machine keys as well as patching the CVEs and getting rid of the web shells in order to eradicate this. So it's a lot of work. and it's a big hassle. Another nice thing about attack flow is you can drop these notes and other kind of contextual data into your flow. So if you're not really familiar with the view state mechanism, this is a open source project on GitHub. It's got a tool that lets you basically forage view state cookies. So you could download this and use this to educate yourself on how this works. You could also hand this off to red team or adversary emulation team, and they could basically conduct an attack very similar to the one that we saw in this flow, and that would help you evaluate your defenses against this real world campaign. And so that's really kind of the main idea of attack flow, is this ability to kind of visualize adversary behavior. In this case, we're looking at multiple incidents or multiple campaigns, and we can easily see kind of what's the common behavior in all of these campaigns, what behavior differs, and then really tell a story or a narrative about this that will be compelling, not just to technical audiences, but also those less technical audiences that are often involved in risk management and decision making. You can find a copy of this flow and learn more about attack flow on our website at ctid.io/flow.